Good morning, children. I hope you all are fine and watching the previous videos and learning all the different concepts. Last time we had studied about Newland's law of octaves and also its drawbacks. The theory failed, and now today we are going to study the next scientist, Dmitri Mendeleev. Dmitri Mendeleev was a Russian scientist. Children, those who have the textbooks, please open to page 17. A Russian scientist, Dmitri Mendeleev. He developed a periodic table of the elements, and that time the number of elements were more. New elements were discovered, and the number reached to 63 this time. Now Mendeleev also used the same criteria for classifying the elements, that is atomic masses. He also arranged the elements in an increasing order of atomic masses. But his observation was slightly different. Now let's see what were his observations. He had organized a periodic table on the basis of chemical and physical properties of elements. These were molecular formula of hydrides and oxides of the elements, their melting points, boiling points, and densities of the elements. Mendeleev found that the elements with similar physical and chemical properties repeat after a definite interval. On that basis, he had proposed a law. Now we'll see what was Mendeleev's periodic law. Mendeleev's periodic law states that properties of elements are periodic functions of their atomic masses. First, we'll understand the statement. Properties, as we have already known, they are physical properties like state, smell, odor, etc. Chemical properties, its combinations with the other elements. So all these properties of elements are periodic. What is the meaning of periodic? Something which repeats after a regular interval of time. Like for example, our school timetable, we have 9 or 10 periods in a day, and each period is of say around 35 minutes. We hear the bell after every 35 minutes, which is repeated at regular intervals of time. So similarly, he found that the properties of elements are periodic, which repeat after a regular interval of time, and their functions of their atomic masses. So all was depending on the atomic masses of these elements. He had a systematic way of classifying elements, and he had prepared a periodic table. In that, if you see on page 18, there is a periodic table. It consists of vertical columns, they are called as groups, and the horizontal rows, they are called as periods. We'll see the structure of the periodic table. Now you can see the periodic table here. Groups. Now this was a Russian scientist, so it won't be groups, it is called as group. The spelling is slightly different. There are 8 vertical columns. Those are called as groups. So we have group 1, group 2, etc. and it ends to group 8. The horizontal rows, they are called as periods. And there are now in the table, there are 12 periods. If you see, we start with the element having the least atomic mass, and that is hydrogen. Hydrogen has atomic mass 1. So we start the periodic table with hydrogen. It is followed by lithium 7, beryllium 9.4, boron 11, carbon 12, nitrogen 14, and so on. So as you see, there is a systematic arrangement of these elements in an increasing order of their atomic masses. But if you have a close look at the table in your textbook, you will see there are dots at certain places. I have highlighted that here. There are blanks over here, 1, 2 and 3 places. So you must be wondering that there are only numbers there, but there are no names of the elements. Why is it so? When Mendeleev had prepared the table, he was sure that these elements have atomic masses 44, 68 and 72. But he was not sure of the names of these elements. So in order to just give it a name, he named them temporarily as Eka boron, Eka aluminium and Eka silicon. 44. The element having atomic mass 44 was named as Eka boron. The element having atomic mass 68 was named by him as Eka aluminium, and 72 was named as Eka silicon. Then if you go down further, you will see some question marks in his periodic table. The names of the elements are there, that is the symbols are there, their atomic masses are given. But before the symbol there is a question mark. So what does this mean? That means Mendeleev was not very sure about the name of these elements, or there must be some ambiguity regarding that element. That is why you can see question marks in the periodic table. If you open to page 19 in the textbook, it's mentioned there. There are some vacant places in the Mendeleev's periodic table. In some of these places, the atomic masses are seen to be predicted, as we have already seen 44, 68 and 72. That means he was sure about the atomic masses of these elements. And due to uncertainty in the names of the elements, you can see the question marks in front of some elements whose symbols are written as well as its atomic masses. Now let us see the merits of Mendeleev's periodic table or their advantages. Merits of Mendeleev's periodic table. While applying the law that the properties of elements are periodic function of their atomic masses to all the known elements, Mendeleev arranged the elements with the thought that the information available till then was not final, but it could change. As a result of this, Mendeleev's periodic table demonstrates the following merits. First, elements were classified on a more fundamental basis on their atomic masses and properties. So, the criteria was the same: atomic masses. Elements were arranged in the increasing order of their atomic masses. Let us see an example. In the periodic table, if you see the previously determined atomic mass of beryllium, Be, see in the table, it belongs to group 2. We have beryllium here, it belongs to group 2 and period 2. It had atomic mass 14.09 and he made the correction, and the exact value now today is 9.4. And beryllium is placed before boron. The second merit: spaces were left vacant to accommodate the elements to be discovered in future. As we had already seen in the periodic table, there were 3 vacant places having atomic masses 44, 68 and 72. So these vacant places, he had given them temporary names as Eka boron, Eka aluminium and Eka silicon. But later on, when the elements were discovered, they were given the names as scandium. Eka boron was replaced by scandium, Eka aluminium by gallium and Eka silicon by germanium. And it was found that whatever Mendeleev had predicted, the properties of these three elements were the same. Let us see an example of that. As you can see, the third merit, it could predict the properties of the elements which helped in the discovery of new elements. What we just now saw, scandium, gallium and germanium. The fourth merit, the inert gas elements discovered later could be placed in a separate group without disturbing the table. If you all remember, inert gases, or they were called as zero group elements. Inert means which do not take part. Now these elements had a stable electronic configuration and therefore they did not take part in any of the chemical combinations or reactions. They were stable. So what he did was, he kept these inert gas elements separately. So it is made into a separate group without disturbing the Mendeleev's periodic table. Now we'll compare the properties here in this table. As you can see, properties of some elements as predicted and discovered later. See, Eka aluminum, which he named, and the new element which was discovered later is known as gallium. The properties which he predicted and the actual, let us go through that. Atomic mass, for example, for Eka aluminum he predicted it would be somewhere around 68 and actually it is found to be 69.7, approximately close. Then the density of Eka aluminum is 5.9 grams per centimeter cube and it was found also actually to be 5.94 grams per centimeter cube. Later if you see the melting point, it is low. He didn't give the exact value, he didn't predict the exact value, but actually today as it is found for gallium, it is 30.20 degree Celsius, which is quite low melting point. Then if you see the formula of chloride, Ea, he had named that Eka aluminum as Ea, so EaCl3, and what is found today, the molecular formula is GaCl3. Ga stands for gallium, Cl stands for chlorine, so the molecular formula also was matching. If you see the molecular formula of oxide, Ea2O3, and today what is found is gallium, Ga2O3. If you compare even for Eka silicon, which is named now today as germanium, the properties are almost similar regarding the atomic mass, the density, the melting point. Now here it is high for Eka silicon, he just predicted, but today actual value is somewhere around 947 degree Celsius. So if you see the table, you can grasp that whatever Mendeleev had predicted has found to be true. So this is more of an accepted periodic table, and these are the merits of periodic table. I hope the concept is clear, and for homework you will study all the laws which we have studied till today with examples. Any doubts, you can note it down and we will solve it later. Thank you.